Hello students, welcome to the second video of the chapter Limits and Derivatives. I hope you must have seen the previous video of limits. Now in this video we are going to learn a new concept which is derivatives. Now what is a derivative? Suppose f is a real valued function. I hope you know real valued function are the functions in which the values of the range is a subset of a real number, right? That means the values of y or fx are only into the set of real numbers. Suppose f is a real valued function and a is a point in its domain of definition, right? The derivative of f at a is defined as limit x tends to a, f of a plus h minus f of a upon h, provided this limit exists. Now, what does this formula tells us? Let's say we know the value of function fx is, let us take example x square plus 2. Now if we have to find f of 2, what we do is 2 to the power 2 plus 2, that is 4 plus 2, 6. Now what if we bring a little bit change? This plus h is nothing but a small change in the value of the variable. See, this is a plus h. A is a particular point. Fx is function in terms of x, which is a general function, like this one. When we talk about, like I have taken this value at a particular point, 2. Consider this as a. A here is 2. If we are calculating the particular value of function at a point, f of 2, it comes out to be 6. What happens if I change the value of variable, like x is equal to 2, to find like f of 2.2? I have brought about a little bit change in the value of x. Earlier x was 2. Now x is 2.2. Right? So this is the value of h. What is h here? H is little bit increase or decrease. I could have taken x is equal to 1.9. So that means earlier x was 2. Now x is 2. That means this is a. Now this is a plus h. So in this case, a plus h is greater. If this is a plus h, here a plus h is little bit less than a. So we can do it either way. If this is 2 and we are bringing a little bit change in the value of x, instead of 2, I have to calculate the value at 2.1 or 1.9. There is little bit change, right? Then if we can define that the rate of change of a function with respect to the change in the variable, right? Now let me explain you. Let the original value of fx at a particular point a, at a, is f of a, right? And then what happens when we take a value of function at little bit closer point? That means at a plus h, f of x becomes f of a plus h. What did we define here? The rate of change of function. Change of function. Change is what? This was original value and this is new value. So what is a change in function? It is the difference of these two. F of a plus h minus f of a, right? So this is the change in function with respect to means divided by change in the variable. Now what is the variable? X, earlier it was a, now x has been changed to a plus h. So what is the difference now? Change in variable is a plus h minus a, and where this limit h is as small as possible. This is a definition. I hope you have got it. How did we derive this function? This is a basic definition. Change in the value of the function f of a plus h minus f of a. This is the new value of the function at a. This is the original value of at a. And here it is a plus h minus a, which is equal to h only. So change in the value of function with respect to change in the value of the variable, and this change is as small as possible. H tends to a. This is called f dash a, derivative of this function at a. Right? So this is a concept. When we derive the formulae or the derivation by this basic formula, it is called the first principle. Right? But in this chapter, apart from learning for the first principle, you will be um, learning few formulae for the basic functions and using them to find the derivative of the other functions. Let us do 2 examples. Find the derivative of at x is equal to 2. See, this is our a. Try to grasp things like this is a of the function fx is equal to 3x. Now what is f dash of 2? F dash of a is, let me write the formula first, limit h tends to 0, f of s a plus h minus f of a upon h, right? Now what is a here? A is 2. What you have to do is a plus h. Now what is fx? Fx is 3x. F of a plus h means whatever x is, replace it by a plus h. So limit h tends to 0. F is what? 3 into x. At the place of x, I am putting 2 plus h because a is 2 here. What is f of a? 3 of 2 divided by h, right? Now we need to simplify this limit. This is 3 times 2, 6 plus 3h minus 6 upon h. Finally, it is limit h tends to 0, 3h by h. So now h got eliminated and the value comes out to be f dash a is 3. Right? This is how we find derivative of a function at a particular point. Let us do one more example. Find the derivative of sin x at x is equal to 0. Again, I am writing the formula. F dash a is limit h tends to 0, f of a plus h minus f of a upon h. The function here is sine of x. So x has to, here a is 0. A is 0. X has to be replaced by a plus h. Limit h tends to 0. Sine of, at the place of x, you put here a plus h. A plus h is 0 plus h minus sine of 0 divided by h. So here we get h tends to 0. This becomes sine h. Sine 0 is 0, right? So we get limit h tends to 0 sine h by h. I hope you must have learned that this formula for limit x tends to 0 sine x over x is equal to 1. So that means this whole thing turns out to be 1. So f dash a or f dash 0 is 1. Right? So this was the basic concept of the derivatives. This is principally called first principle. First principle to find the derivative of a function. And later on you use these formulae, basic formulae to find the derivatives of the other functions. I hope you liked watching this video. If you have any doubt or you want to take classes, do contact me through our group. Thank you.